Good morning, good afternoon, and good evening to all our customers joining us across the globe. Hello, everyone. My name is Lokesh Sharra, manager for the Arista Technical Services team, and I would like to welcome each and every one of you to the first webinar hosted by the Arista Technical Services team in the year 2023. And before we begin, I would like to thank you all for this overwhelming response. Our team here has put in a solid work to ensure these sessions are able to provide you with a great insight into the Arista EOS and the Cloudvision world. And we really appreciate this overwhelming response we have received from our customers on these technical webinars. For the customers who are joining us for the first time, we actually kicked this effort off in September 2022. And we did 3 webinars last year where we covered details about the general health checks on the Arista EOS and Cloudvision, tricks and tips regarding switch upgrades and planning your maintenance activities for MLAG and the modular devices. In 2022, we covered this from the CLI side and also from the Cloudvision side for the customers who are actually planning to automate that environment. So if you would like to reference these previous recordings, they are available on our community pages, which we will be sharing the links shortly in our chat windows. A little bit about the webinar initiative itself. This is an initiative where we actually want to provide an opportunity for the Arista TAC and our end customers to connect outside of the usual problem-solving scenarios. And with these webinars, our aim is to work on the knowledge sharing with our customers and cover topics which are applicable to all our customers in depth. So for the 2022 series, we started with some baseline details and the topics. And as per the feedback we received from the field, we are actually going to venture out into more technical topics this year. So for the first session here today, Sarthak, could you move on to the next slide, please? We are going to actually cover a Layer-2 setup. So we are going a bit different from the approach what we had last year. And we are going to cover a Layer-2 setup and how to effectively debug the traffic flow related issues in such a setup. So in this webinar, we are actually going to walk through a lab topology, which closely mimics any typical small-scale Layer-2 setup, but this can actually be applicable for any large-scale Layer-2 setup. So the debugging steps actually remain the same. Our speakers, Sarthak, will be highlighting this topology in between the debug scenarios, but we have already put this topology in the chat window as well as in the QA section. So it will definitely be a good idea to take a snapshot of this topology or download this topology from the Ignite link, which is available, and keep it handy during the course of the presentation for reference. A little bit about the schedule in 2023. Sarthak, could you please move on to the next slide? We have 3 sessions which are planned in Q1, and these sessions will be accessible via the same registration link. We are planning to actually come up with 3 more sessions in Q2, and after which we are going to take a break for 2 months to ensure that we put together quality material on more complex topics like EVPN, which we are actually going to cover later this year. And after that, we are actually going to resume in September for 3 more sessions, and then we'll wrap it up in November for 2023. So this way, you will have our spring, summer, and fall collections of the webinars, and a separate registration link will be provided and will be required for each of these webinar collections. For today's session, we have 2 of our best engineers with us who will be taking us through today's details. We have Sarthak Shetty, who will take us through the CLI component, and then we have Himanshu Singh, who will run with the Cloudvision side of the presentation. Again, these sessions will be recorded, and all the material will be made available on the Arista community pages if you'd like to have access to this material moving forward in future. Along with the presenters, we also have our technical leads as part of the panel who can actually help you answer any questions you may have during the course of the presentation. You can actually use the Q&A manager to ask our panelists any questions during the presentation. And we, again, will try our best to get to all the questions, but in case we are not able to get to all during the stipulated time, we'll actually follow up via email after the presentation. And if there are any unforced error, we do apologize in advance, and we'll be looking out for feedback to make any improvements. And before I hand off to to Sarthak to take you through the CLI part again, I would like to emphasize that there's a topology. The link is available in the chat and the Q&A both sections. So please take couple of minutes to actually go through that link. There's a Ignite link which is available, so you can download it from there. And Sarthak will be flashing the topology on the screen in a minute to actually, you can take a snapshot of that and you can keep it handy during the course of presentation. So without taking any further time, I'll hand it off to Sarthak to take you through the CLI part. Sarthak, take it away.
Thank you, Lokesh. Hello, everyone. My name is Sarthak Shetty. I've been with Arista TAC 6 years and counting, and I primarily work with the data center technologies. Today, we'll talk about debugging layer 2, and I'll be showing the CLI troubleshooting part. So here is the topology we'll be using today. So we have hosts connected to Arista switches here. Arista 1 and 2 are an MLAG. And then on top of that, we have Arista 3 and 4. And then again, there's host connections. You can see the EOS and the model numbers of the Arista switches which we are using. Also, you can see the IP, VLAN, and MAC addresses of the hosts being used. We also have streaming to CVP configured. So this is a sample layer 2 network. In the forthcoming troubleshooting video, we will focus on hop-by-hop troubleshooting and the next steps to be taken while debugging layer 2. Once again, please download the diagram from the link provided and keep it handy, keep it open on your computer. We will also keep posting the download link in chat at regular intervals. We have two problem statements here. So the first problem statement is that the connectivity between end host 1 and host 2 is impacted. The pings from host 1 to host 2 are unsuccessful. So we'll go through the troubleshooting steps to be taken in such scenarios. This slide contains some common symptoms and common checks which we do in such scenarios. All of these will be showcased in the video. There's also Arista Community Central articles and arista.com articles which will be referenced in the video. So here you can see we have the troubleshooting video on the left and the diagram here on the right, which depicts the problem. As you can see, host 1 here at the bottom has the IP 10.0.0.1. It cannot ping host 2 here at the top left, and host 2 has the IP 10.0.0.2. Both are in the same subnet. So let's go through the troubleshooting video. I'm going to use a local copy. So the setup here, you can see host 1 and 2 at the bottom, Arista 1 and 2 at the top, and then Arista 3 and 4 on top of them. So let's start the pings to host 2 from host 1. And we can see the pings are unsuccessful. So the next thing to check is what's the next hop for these packets. From the diagram, we can see Ethernet 2 from Arista 1 and 49/1 from Arista 2, they connect to host 1. We need to check if these packets are indeed making it to the switches and what interface will receive the packet. Now, these switches are in MLAG. From the previous webinars, you might be aware of MLAG technology. In MLAG, two switches act as one logical switch in layer 2. Interfaces from both these switches can then form a single logical MLAG port channel. So here, Ethernet 2 from Arista 1 and Ethernet 49/1 from Arista 2, they form MLAG port channel 1, which then connects to host 1. So let's take a look at the config and state for these interfaces. And for that, you could do show running config. And here it's Ethernet 2. We can check that. Just keep an eye on the cursor. I'll be moving the cursor at the output and the part which I'll be talking about. So just keep an eye on there. Let's take a look. This is a trunk port, and it's been configured for port channel 1. Let's check the same thing on the other side. We can use abbreviations for the command, as you see. This is also a trunk port, and it's been configured for port channel 1. All right. Let's take a look at the state of this interface. For that, it's show interfaces, and again, Ethernet 2. We see it's up and connected, everything is fine. This command also tells you the MTU details, the speed and duplex settings, gives you the input-output packet rate, the type of packets you're sending and receiving, any layer 1 errors, any input or output discards. So this is a very good command to check the state of any interface. Let's check the same thing on the other side. It's 49/1 here. Again, I'm using abbreviations. It's up to you how you want to run the command. We can see 49/1 is also up and connected. So everything is fine for the interfaces. Let's check the port channel now. Same thing, show interfaces, port channel, and it's port channel 1 here. We see it is down. It says line protocol is lower layer down with a not connect status. So let's check if it's the same on the other side. We see port channel 1 is down here as well with the same reason. So there is some problem with port channel 1. It's not connected. So we should take a look at the members of this port channel. For that, you could do show port channel and the number. So you can see there's no active ports in this port channel. Ethernet 2 has been configured. However, it's waiting for an LACP response. Let's check the same thing on the other side. So port channel 1. And we can see no active ports here as well. And 49/1 is also waiting for an LACP response. LACP stands for Link Aggregation Control Protocol, and it can be used to form port channels. Both sides of the link should send and receive LACP packets, which we call as LACP DUs. They negotiate on certain details, and then they form an aggregate or a bundle. Seems like there is some problem with LACP here, and we are not receiving packets. So let's check the LACP state. And for that, you can use the command show LACP internal detailed all ports. As you can see, this tells you about the system ID to be used, the LACP flags, which depict the state. But we can see Ethernet 2 has no aggregate, whereas for a successful port channel 10, its member interfaces are bundled. Ethernet 2 has no idea about its partner's system ID. It's all zeros. Whereas for the successful port channel 10, you're receiving the same system ID from its partner on both the links. We can see the state is S-, which stands for out of sync, as you can see. Whereas for the successful port channel, it's S+, which is in sync. The MUX state is also detached, whereas for the successful port channel, it's collecting, distributing, which means we can send and receive packets. So let's check the same command on the other side. These are in MLAG, so the layer 2 database will be the same. We should do the same checks. And we see Ethernet 49/1 also has no aggregate, has no idea about its partner. It is out of sync, and the MUX state is detached here as well. We also have an Arista Community Central article, which explains this LACP troubleshooting in detail. So please take a look at that later. But here it does seem like we have no idea about our LACP partner. So let's check if we are sending and receiving LACP packets properly. For that, you can use show LACP counters all ports. Just a thing here, you see the counters are pretty high, but we use these switches for testing. That's why the counters are high. But what we are concerned about here is, are we sending packets? So TX, and are we receiving packets properly? So the RX. So we'll need to run the command again. And we see the TX counter did increment. However, the RX did not. Let's run it again. Again, we can see the TX is incrementing, but the RX is not. Now, instead of running this command multiple times, what you can do is you can use some Linux facilities here. So let's go to the beginning of the command and write watch. This automatically refreshes the output every 2 seconds. And then diff will highlight any differences, anything which is changing. So now you see the command is refreshed every 2 seconds and any changes are highlighted. So you can see the TX counter, it's consistently incrementing. However, the RX counter is not. So we are sending, but not receiving packets. Let's check the same thing on the other side. Watch diff is really helpful. so that you don't need to run the command multiple times. And we see TX is incrementing here as well, but the incoming or the RX is not. Keep in mind, while LACP is negotiating, the packets are sent every 1 second. Once the bundle is formed, if we have rate normal, we expect to receive packets every 30 seconds. So now let's do a TCP dump capture and check what control plane packets are we receiving. On Arista switches, you can directly go to the Linux shell by using bash. Now from here, we can run any Linux command. We want to do a TCP dump for Ethernet 2. We only want to see the incoming packets, so -q in, and I'm going to filter for LACP packets. So I'll use the Ethernet protocol for LACP. Now I'll copy this and I'll run the same thing on the other side. Now you don't necessarily need to go into bash. You can run any bash command from CLI, just prepend it with bash. Here we need to change the interface number. It's 49_1, which is Linux. You can use ifconfig to find out the Linux interface naming. But as you can see, we are indeed not receiving LACP packets from host 1. So now we need to check on the host side if the lag or the port channel has been configured properly. In most scenarios, the NICs on the host or the VMs, they are not bonded properly. This needs to be rectified by the team or the vendor handling the host. Now on our side, I've applied the required config on host 1. I've made sure they are bundled into a port channel, and soon we should see the packets coming in. There you go. We see the LACP packets are coming in from the host now. So let's again check the counters and make sure the packets are indeed coming in. We can see 49/1 has been bundled, so everything is good there. Let's check the same thing on the other side. However, Ethernet 2 is still in negotiation. But let's see if we are sending and receiving packets properly. And there you go. We see the RX and TX both incremented now for both the interfaces. So it seems like we are receiving and sending LACP packets, but Ethernet 2 still has some problems being bundled. So again, let's check the state of the port channel, show port channel 1. And we can see Ethernet 2 says partner is not in sync. Let's check the same thing on the other side. Here, the port should be bundled. So yes, you can see 49/1 is active. So if we see sync issues, we should check, are we sending proper details in the LACP packets? Usually this signifies issues with the system ID. So now let's check what are these Arista switches sending out. Again, we can do a TCP dump, but now we only want to see the outbound packets, so -q out, and then the LACP protocol filter. These are all Linux commands and flags, so you can easily get that. You search for it. And again, 49/1 here. Now it might take some time as we are exchanging packets once every 30 seconds. The bundle has been formed, right? So now the packets will be exchanged once every 30 seconds, since by default, we have LACP rate normal. If rate fast is configured, packets will be exchanged once every second. So let's wait and see what are the packets we are sending. There you go. These are the packets we are sending out. Active stands for ourselves. So this is ET49/1 here. And you can see it is sending a packet with the system ID ending in 971B. Whereas Ethernet 2 is sending a totally different system ID. This ends in 9A93. You can see the partner, the host, is sending us the same system ID on both the links. So both interfaces on Arista 1 and 2, they're identifying themselves with different system IDs, and that is causing sync issues. The system ID should match on both the links to form a port channel. You can also use the command show LACP system ID to see what system ID can be used by these interfaces in LACP. We can see the common system ID, which needs to be used by the MLAC switches, since they are acting as one logical switch in layer 2. For that, we'll have to bind this port channel 1 on both switches into one logical port channel. So let's check the running config for this port channel. What do we have here? We can see it's an access port in VLAN 10. Let's check the same thing on the other side. Again, just an access port in VLAN 10. So there is nothing which binds these two port channels together. In such scenarios, a common MLAG ID is required, and this will bind the port channels on both devices into one single port channel. Let's go to the config mode for port channel 1. Another good command you can use is show active. This shows you all the active configurations under a particular mode. So now let's go ahead and configure the MLAG ID. This can be any number between 1 to 2000. Just make sure it has to match on both sides of the port channel. This will bind it together. So let's give this MLAG 1. And then on Arista 1 as well, let's go to the port channel config and make sure you're adding the same MLAG ID. Now let's check the state of the port channel. And there you go. We can see the local interface Ethernet 2 is active. It also tells you what's the interface on your peer, on your MLAG peer. Similarly, let's check on Arista 2. You can see the peer Ethernet 2, the interface on your MLAG peer, and your local interface. They are both active. So now the LACP and port channel state looks good. However, we can see the pings are still unsuccessful. So let's talk about the packet path. Before sending ICMP packets, the host should get the ARP resolved for the destination, right? So let's take a look at the ARP table, and we can see host 2's ARP is incomplete. So let's start the ping again. Now host 2 is in the same subnet. So host 1 can directly ARP for host 2. And we know it is going to send an ARP broadcast package for 10.0.0.2. Now this packet will be hashed out of one of the interfaces in the port channel, and it can land at either Arista 1 or Arista 2. It's hashing. So on the switch, we can use certain commands to learn where the packet was hashed to. A good command to use is show interfaces, give your interface name, and counters bins. We'll also use the watch diff facility as we want to see what is changing in this output. Now let's run the same thing on the other side. So this command tells us the input and output packet counts for every packet size. You can set the packet size for a particular flow and then make sure if this flow is coming in or going out of the interface. Now, if there is other traffic of the same size, we won't be able to differentiate it. But in this scenario, we know that the ARP packets, the ARP requests which are coming in, they are 28 bytes in length. So we should see the 64 byte below counter incrementing, and we can see it's incrementing for 49/1. However, for Ethernet 2, it's not incrementing. So this tells us that the ARP requests are coming in on 49/1 of Arista 2. Now, another important thing is whenever switches receive a packet, there will always be MAC learning. Switches always learn the source MAC address from an incoming packet. So let's check the MAC address table. And we see host 1's MAC address is indeed learned on port channel 1 in VLAN 10. Now this MAC address will also be synced with the MLAG peer, right? This is in layer 2. So MLAG should have the same databases in layer 2. So let's check the MAC address on Arista 1. And we see host 1's MAC address is indeed learned on Arista 1 as well. And it's learned on the shared port channel 1. But the MLAG peer told us about this. So we should also see it learned with show MAC address table MLAG peer. And we see we are learning the MAC address courtesy of the MLAG peer. If we check the same command on Arista 2, we don't see host 1's MAC address learned via the peer. This is because Arista 2 is learning it locally and then syncing it with the MLAG peer. So this also lets you know which peer received the actual packet and which peer learned it via MLAG. Now going back to the ARP broadcast packet, it's received in VLAN 10. So it's going to be sent out of all ports in the same VLAN, except the port in which it was received on, right? So let's check show VLAN ID, show VLAN 10 to give us all the ports in VLAN 10. So this tells us where the broadcast packet can be sent out of. The broadcast packet is also sent via the peer link to the MLAG peer. So you do see port channel 10, but the peer will not again send it out of any MLAG port channels. It's only going to send it out of the orphan or the single interfaces. So we should now check what are the devices connected to these interfaces who will receive this ARP broadcast. For that, you can use show LLDP neighbor. Same thing on the other switch as well. And there you go. We can see, apart from the hosts and switches which were already discussed, the broadcast will also go to Arista 3 and 4. So on these devices, when they receive the ARP request, based on MAC learning, they should learn the MAC address of host 1, correct? So let's check the MAC address table on these switches as well. Let's increase the terminal size to make it a bit easier for viewing. And let's check the MAC address table. And we do see host 1's MAC address is learned on Ethernet 3, which means from Arista 2. Let's check the same thing on Arista 3. And we can see Arista 3 is not learning the MAC address. The ARP request should have landed here, provided there are ports in VLAN 10. Host 2, which is a destination, it is connected to Arista 3. So it seems like the ARP request never made it here, hence the communication is broken. So let's check the ports in VLAN 10 on this switch, which ports will receive the packet. And we see only Ethernet 1 and 51/1 are in VLAN 10. But what about Ethernet 8 and 3 from the diagram? Let's check their config as well. And we know the command show running config. You can also give multiple interfaces in the command, just use comma. And we see both of these are trunk ports. So they should allow all the VLANs, but we still don't see VLAN 10 allowed on Ethernet 3 and 8. So an important command to check while you're working with trunk ports is show interfaces trunk. This gives you the native VLANs, the allowed VLANs, but the most important thing is the VLANs should be in the spanning tree forwarding state. We can see Ethernet 1 and 3 have no VLANs allowed, and Ethernet 8 only has the native VLAN allowed. So now let's check the spanning tree state using show spanning tree command. So we can see the STP flavor is MST, which is Arista default. And we can see Ethernet 1 and 3 are in alternate discarding mode, whereas Ethernet 8 and 51/1 are in forwarding. Now, this is because of the flavor of the spanning tree used. However, since Ethernet 8 is forwarding, VLAN 10 should have been allowed here. Now, what could be happening here is that VLAN 10 is part of a trunk group, and hence it's being restricted to certain interfaces. So let's check if there is any trunk group config for VLAN 10. For that, we could do show VLAN 10 trunk group. And we see it is indeed part of the trunk group DB traffic. If a VLAN is part of a trunk group, then only the interfaces containing this trunk group will allow the VLAN. So let's check if the running config contains anything for this particular trunk group. We could do show running config and use the command section, another important thing, followed by whatever string you want to search in the running config. So I want to search for DB traffic. So let's do that, section DB traffic. And there you go, it tells us everything which has DB traffic. VLAN 10 is configured for it, and only Ethernet 1 has been configured for DB traffic. Does seem like a misconfig. Now let's also check the running config for 51/1 to be safe. What's going on there? And we see it's an access port. So it has nothing to do with these trunk groups. Hence, VLAN 10 was allowed on 51/1. So now we know there is a misconfig, and we need to configure this trunk group on appropriate required interfaces. Let's go ahead and configure it for both Ethernet 3 and 8. Again, we could give multiple interfaces in the config mode. Let's go ahead and configure the trunk group. So switch port trunk group and the name of the trunk group. And now you can see as soon as it was configured, the pings are now successful. So basically, the trunk group was missing on Ethernet 8, and hence VLAN 10 was not allowed on the port. This caused communication to break in the VLAN 10. We also have a summary. So let's go ahead to the slides and take a look at the summary for this problem. Again, here is the problem statement. Host 1 is not able to ping host 2. So the first thing which we checked is check the ARP on the host. We'll send ARP request if the ARP has not been resolved. But once the ARP is resolved, then we'll send the ICMP packets or whatever protocol we are using. So here we saw that ARP was not indeed resolved for host 2. So then we went ahead and checked what's the next stop. Where will these packets go to? So it will go to Arista 1 and 2. We had the interfaces which will be involved, Ethernet 2, 49/1, and port channel 1. So we checked the config and state of the interfaces involved, which can receive this packet. We saw that the port channel itself was down. So then we needed to do some LACP troubleshooting. And from that, we found out that the host was not sending any LACP packets. So we had to go ahead and make sure the config was needed. The config was present where the NIC will be bundled to form a successful port channel. So after that, we saw that port channel 1 was up and connected. So next thing is we should verify the path of the packet or the next hop for the packets. So for layer 2 packets, we checked the MAC address table and the VLAN state. And we also checked counters per bins. This helps us find out where the ARP request was received and where it will be broadcasted to. So based on that, we saw that the ARP request was received on 49/1. So here is the expected traffic flow with the green arrow. And then we knew that from the MAC address and VLAN state, it's going to be sent out of all ports in the VLAN. So according to that, we should see the packet landing on Arista 4 and 3. Arista 4 was learning the MAC address successfully on Ethernet 3. However, Arista 3 was not learning the MAC address. And we checked the state of the interfaces here. We found out that Ethernet 8 should ideally receive the packet. But then when we checked it, we saw that the trunk port did not have the VLAN allowed. So Ethernet 8 did not have VLAN 10. Did some further checks and found out that there is a trunk group config for VLAN 10, and it was not allowed on Ethernet 8. So once we configured the trunk group, traffic started flowing as expected. So the problem was VLAN 10 was not allowed here on Ethernet 8. The trunk group config was missing. And you can see all the commands which we have used on the right side here. They are also color coded according to the block of troubleshooting. So the port channel first, then the packet path, and then followed by the trunk port related config. So that concludes problem 1. Let's go ahead to problem 2. And if anyone has just joined or joined in between, please download the topology diagram from the chat. We have posted an Ignite link. It will help in the troubleshooting video, and it will be good if you could take a look while I'm going through the CLI troubleshooting. So let's talk about problem 2 now. In this problem, host 5 in VLAN 10, it's trying to ping its default gateway, which exists on Arista 3. The pings are unsuccessful, and during this activity, switches are also complaining about MAC and host flaps. In this slide, there's also the troubleshooting steps, which we'll do in the video. And there's also the Arista Community Central articles, which we have included, which will be referenced in the troubleshooting video. So please take a look at them later. Now let's go to the problem slide. Again, the video here, and on the right, you can see the problem statement depicted. So host 5 here, it's trying to ping host 5 on the top right. It's trying to ping its gateway in VLAN 10. So for that, we just configured a switch virtual interface, SVI VLAN 10 on Arista 3. You can see the IPs are 10.0.0.254 for the gateway and 0.5 for host 5. So these pings are unsuccessful, but during this activity, the switches are seeing host flaps or MAC flaps. So let's start the troubleshooting. I'm again going to use a local copy to be easier. So the same setup, instead of host 1, I'm using host 5 here. Now, since the destination is in the same subnet, we should check, do we have the ARP? We can see we don't know the ARP for the gateway. So before we send any ICMP packets, host will always send an ARP request first. It will try to get the ARP resolved and then send ICMP packets. Now, these ARP requests are broadcast packets in the VLAN. Let's start the ping and see what's happening. Pings to the gateway. So we can see the pings are unsuccessful as per the problem statement. Let's minimize this tab and keep the pings running. Now, according to the problem statement, we are seeing host flaps on the switches. So let's go to Arista 4, which is directly connected to host 5. Now, to check any events going on in your switch, we can take a look at the switch logs by using the command show logging. I've included an article which explains EOS logging in detail. So let's run the command show logging. Let's increase the terminal size. So you can see it gives us logging levels for each facility. It also shows logs going back a few days or a few months, depending upon the logging buffer. But since it's a huge output, you might need to scroll a lot. Instead, we can use variations of this output. So if I only want to see the most recent 50 lines, I could do show logging 50. You can put any number there. And here you see only the most recent 50 lines are shown. I can also specify time units with show logging last. And as you can see, I can specify seconds, minutes, hours, or days. So if I only want to see logs for the last, let's say 2 minutes, I can just write show logging last and whatever number you want, right? So 2 minutes, and you can see we only see logs for the last 2 minutes. So this helps in checking the syslogs for a specific time window. Now from the logs, we can see the MAC address of host 5 is flapping between Ethernet 2 and 3. Since the MAC address is flapping, we should also check the MAC address table. So we know the command show MAC address table, and let's utilize the watch diff function so we don't have to keep running the command multiple times. Now you can see the MAC move counter is constantly going up. The port is also changing between Ethernet 2 and 3. If the MAC moves are incrementing, it's a cause for concern. It can cause impact in your network. Another thing which we can check is Event Monitor. Event Monitor receives notifications for important events or changes happening on your switch, and it writes these records to local files. I've included an article which explains Event Monitor in detail. Beginning with EOS 4.20.5, Event Monitor is not enabled by default, so we need to run Event Monitor. This enables it. And now we can check the options here. So show Event Monitor, and you can see all the different options you have. Here, we are only concerned with the MAC. So we can do show Event Monitor MAC. And there you go. It tells you the date, the timestamps. And as you can see, the timestamps are very intricate. It gives you nanoseconds, milliseconds, tells you what's going on. And we can see the MAC address is flapping between Ethernet 2 and 3. It's constantly being learned dynamically. It's constantly being added and removed between these two ports. So these are all the ways you can verify the events happening on your system. But coming back to the problem, we see the host is flapping between Ethernet 2 and 3. This means we are learning the same MAC address from both these ports and in the same VLAN. Whenever we see such MAC flaps, we should trace the source of the packet and check what is connected on these interfaces. So let's check what is connected on Ethernet 2 and 3. Again, we can use show LLDP neighbors. You can specify multiple interfaces. We're going to use the detail part of the command here. We want to know more about our neighbor. So as you can see, Ethernet 2 is actually directly connected to host 5, and we can get that from the diagram as well. So it is expected to learn this MAC address on Ethernet 2. However, Ethernet 3 connects to Arista 2. So we should not have learned host 5's MAC address on this interface. So now we need to check what packets are we receiving from Ethernet 3, from Arista 2. Why are we learning this? So in order to get packet captures, we can use the mirror to CPU feature. In regular port mirroring, we usually define a source port, and then we create a copy of the packets coming in or going out of this port. We then send this copy to a destination port and have a device connected to the destination port to analyze the packets. Pretty intensive, right? But now with Arista switches, you can use mirror to CPU feature where we can mirror the packets directly to the CPU on the switch. You don't need any extra device. So far, we have done a TCP dump capture on the switch interfaces directly. Now this will only show you the control plane traffic, the CPU bound traffic for those interfaces. But to run capture for the data plane traffic, we can do the mirror to CPU feature. And let's take a look at the config which is needed. So you can do monitor session and then give a name for that session, anything which is easy for you. For me, I'll just use test ET3. Then you specify the source interface. Which interface do you want to create copies of the packets coming in and going out of? So we want to see the packets for Ethernet 3. And here are the options. You can filter based on IP, IPv6 MAC access list. But here we are only concerned with the incoming packets, right? So we'll configure mirroring in RX direction, only in the receive direction. Now with the same CLI, we need to specify the destination port. So you can see we have all these different options for mirroring, but we want to send these packets to the CPU on the switch to make it easier. That's done. Now let's check show monitor session to get the mirror port which is created. So you can see this is programmed in hardware, and mirror 0 is the port which is created. So now we just need to run a TCP dump on this mirror port, and it will give us both the data plane and control plane packets. So this is a very cool feature to see all types of packets coming in or going out of your port. So let's do TCP dump for mirror 0. We see some STP packets, but we also see some ARP request. So let's stop the capture. Let's take a look at this ARP request. So this is a request for the gateway sent by host 5. You can verify with the IP address and the MAC address as well. So this is not expected. We see host 5's packet coming in on Ethernet 3 as well. So this leads to the MAC flaps between ET3 and 2. Arista 2 is connected to Ethernet 3. So let's go to Arista 2 and check what's happening here. Why is it sending us host 5's packets? Again, show logging. I only want to see the last 10 lines. And what do I see here? The same host 5's MAC address is flapping between the peer link and your local interface Ethernet 2. So it seems like we are receiving host 5's MAC address on Ethernet 2 and from the MLAC peer Arista 1. So again, let's trace the source of the packets. Let's go to Arista 1. Let's check what's happening here. And we'll again use syslogs. We see host 5's MAC address is flapping on Arista 1 as well. It's flapping between the MLAC peer link and local interface Ethernet 23. So it seems like these switches are receiving host 5's packets on their local interfaces, and they're also exchanging it via the peer link. And this causes the MAC flaps. Now, Ethernet 23 and Ethernet 2 connect to host 4. So again, let's trace the source of the packets. Let's check what packets are we receiving on these interfaces. Same thing again, we'll do a monitor session. And we specify the name for the session, whatever is easy for you. Specify the source interface, Ethernet 23. I only want to see the incoming packets. So Ethernet 23 RX, same CLI. Now to specify the destination, I want to send it to the CPU and then show monitor session to find out the mirror port which is created. It's mirror 0 again. Now all we need to do is run a TCP dump on this port which is created. And there you go. We still see some ARP request, and it seems like it's the same ARP request. Host 5's ARP for the gateway is also coming in on Arista 1. Let's check what we are receiving on Arista 2. Same commands again. And I've included all the articles for mirror to CPU and port mirroring in the slides. So definitely take a look after the session. So we want to see packets coming in on Ethernet 2 here. Same CLI, just the interface numbering will change. Let's check the mirror port which is created. To monitor session, and we can see it's again mirror 0 here. So let's run a TCP dump. Just keep in mind, once you configure more monitor sessions, the mirror port numbering will change, but you just need to run a TCP dump on the mirror port for that interface. So let's run this. Again, we see the same ARP request. There's also some LDP packets, but let's stop it. Let's check this ARP request. It's literally the same packets. It host 5's ARP request for the gateway is also coming in on Arista 2. So what does this mean? This means host 5's ARP requests are somehow arriving at host 4, and host 4 is broadcasting it out of both the interfaces towards Arista 1 and 2. This is only possible when there's an unwanted connection or a cabling mistake between the hosts. So now again, we need to involve the appropriate team, take a look at the network with the host and rectify any mistakes. So in our setup, there was indeed an unwanted link between host 5 and 4, and we shut that link down. This way, the ARP request will no longer arrive at host 4, and the ARP broadcast storm will be contained. So now let's check the MAC address table on these switches. Let's check if these flaps have indeed stopped or not. So we again know the command for MAC address, show MAC address table, and let's use watch diff so that we don't have to run the command multiple times. And we see the moves counter is not going up. The last move counter is going up. This is a good sign because it tells us the MAC hasn't moved since these many seconds, these many time units. Let's check the same thing on Arista 2, and we can see the move counter is not going up here as well. Let's check the same thing on Arista 4. The MAC was flapping on all of these switches. Now let's see, and there you go. Moves counter is not going up, only the last move counter is going up. This is good. So we have stopped the MAC flaps. Things look good here. But there is another problem which we noticed here. Let's go to the diagram to take a look at it. So host 4 sent the packet to Arista 1. Arista 1 learned the MAC address on Ethernet 23. This is a broadcast packet, so it was sent via the peer link to Arista 2. Arista 2 learned the MAC address on the peer link as well, but it got the same packet on Ethernet 2. Host 4 also sent the same packet here. So this led to MAC flaps on Ethernet 2 and the peer link. Arista 2 again sent that broadcast packet out of the peer link. This led to MAC flaps on Arista 1's peer link and Ethernet 23. So the thing to keep in mind in such layer 2 environments is that whenever a host is connected to two switches in MLAG, either put them in a port channel, just like port channel 1. This way, both Arista 1 and 2 will learn the MAC address just on the shared port channel, and they'll also receive the packet only on one of the links. Or keep the NICs in an active standby scenario, where the second NIC will come up only if the first NIC is down. So basically send the packet on only one of the interfaces. So this is a thing to keep in mind when you're working in layer 2 environment, when a host is connected to the Arista switches in MLAG. So we made those changes on our setup as well. And as we have seen, the host flaps have stopped. Now let's go to the pings to the gateway. Were those rectified? Did we take care of them? And you can see the pings are still unsuccessful. So now let's go to the gateway. As we know, it's Arista 3. We have configured an SVI. So let's check the state just like we did before. Show interfaces VLAN 10. So here we can see the IP of the gateway. It's correctly configured. Gateway is up and connected as well. So the ARP request for this gateway, they should come in on the ports in VLAN 10. So next step, again, let's check the running config for this interface and also the ports in the VLAN, just like we did in problem 1. Show running config and then the interface name. We see there's nothing much here. It looks good, just the config for the gateway. And now, like I said, the ARP request should come in on the ports in VLAN 10. So let's check that. CPU stands for the SVI created, since it's a CPU bound interface. And then you can see all these other ports in the VLAN 10. So let's check the spanning tree status for these ports. And just like in the previous problem, we can see Ethernet 1 and 3 are in alternate discarding, 8 and 51/1 are forwarding. Now Ethernet 51/1 connects to host 2, as you can see in the diagram. So the ARP request should ideally come in on Ethernet 8, right? So let's check the running config for Ethernet 8. So we can see it's a trunk port, good. It also has the trunk group for VLAN 10 allowed. Hence, we did see VLAN 10 was allowed here, but we also see there is a MAC access list which is configured in the inbound direction. Just like an IP access list is for layer 3 ports, a MAC access list is for layer 2 ports. And we can filter based on the layer 2 header. So let's take a look at this ACL, at this MAC access list. And we can use the command show MAC access list and the name. So it's Arista 3_MAC ACL. So you can see there are 3 different entries. Just like an ACL, you specify the sequence number. And then here we are permitting packets. So we are permitting packets with these certain source MAC addresses. And keep in mind, you have to specify a wildcard mask in a MAC access list. So you are permitting certain source MAC addresses going to any destination MAC address, and then you specify the ether type. So here we are permitting IP packets, ether type of IP. There's also source MAC address from certain source MAC address to any destination MAC and IP packets. There's also counters per entry. Counters per entry helps in statistics. So if any traffic is coming in on Ethernet 8, and it matches any of these access list entries, we'll see a match counter go up. This helps in verifying if certain packets are indeed coming in or going out of the port, depending upon the direction of the access list applied. All access lists also have an implicit deny at the end. So any traffic which does not match these entries, it will be discarded. Now what we see is there is no entry which permits the ether type of ARP. ARP has its own ether type. So therefore, it's possible that the ARP requests which come in, they don't match any of these entries, and then they are denied by the implicit deny at the end. This leads to maybe packet drops or ARP not being resolved. So let's go ahead and configure the access list and add an entry to permit the ARP packets. So config mode, MAC access list, the name. We need to give a sequence number, can be anything. So let's give 40. Let's permit packets. Then specify the source MAC you want to permit. For simplicity's sake, I'll just do any. So any source MAC address going to any destination MAC address. Now the ether type, I want to permit, as you can see, ARP packets. Let's add it. Also, let's do show active. The command we need check to see the active config. You can see number 40 is still not active. So another key point while working with access list, if you want the configs to take effect, you have to exit out of the access list. So let's maximize the ping tab and let's exit out of the access list for the config to take effect. We have done that. And now you can see the switches do learn the MAC address of the gateway and the pings are now successful. So we just needed to add an entry which permits the ARP packets since we see the ARP was not resolved. Let's also check the counters per entry here, right? So we need to do show MAC address table, show MAC access list, and you can see the counters. Let's maximize this tab as well. And you can see the ARP entry does have a match now. So the initial ARP request was permitted, the ARP was resolved, and then host 5's MAC address, source MAC, you can see we have matches for that as well. So the ICMP packets started coming in. Let's do a watch diff. And yes, we can see the ICMP packets are incrementing because we are sending pings. So we do see matches for the packet. Let's stop the pings. And there you go. The match counter has also stopped incrementing. So counters per entry is really helpful if you want to see if certain flows are coming in or going out of your interface. And it helps you with the match counter statistics. Now, just one more last thing which I'd like to show is in case you see any kind of misbehavior with your MAC addresses, you can also check the platform MAC address in hardware. So let's go to Arista 1 and 2. Let's do show platform. And depending upon that, so here it's show platform FAP, and then you could do MAC address table. And you'll see the MAC addresses programmed in hardware, and then the chip where it's programmed on. Arista 2 is of the same model, so let's run the same command here as well. Show platform FAP, MAC address table. And we see the MAC address is programmed in hardware, and then just the chip where it's programmed. Arista 4 now, this is a different platform, so depending upon that, change the command, but it's the same show platform and then MAC address table. And we can see these MAC addresses are programmed in hardware. So everything looks fine here. We have taken care of the MAC flaps and the pings to the gateway. So let's go back to the slides. Let's take a look at the summary. Host 5 at the top right was trying to ping its gateway on Arista 3, which was basically an SVI configured for that VLAN. The pings were unsuccessful, and we saw MAC flaps on the switches. So the first thing, just like in problem 1, the host will always check if it has the ARP, since the destination is in the same subnet. Only after the ARP is resolved, it sends the ICMP packets. We saw that the ARP was not resolved for the gateway. So then we know that host 5 will send ARP request for the gateway. So the next hop was Arista 4. Here we did see MAC flaps. So then we checked the events happening on the switch. We used the syslogs, we used event monitor, and then also checked the MAC address table for any flaps or moves. We also trace the source of packets whenever we are seeing MAC flaps. Again, we can use MAC address table, LLDP neighbors, and then also take packet captures on appropriate interfaces to verify what packets are we receiving. For that, we used mirror to CPU sessions. And what we saw is we were receiving host 5's ARP packets from Arista 2 as well. So again, we just trace the source of the packets, go hop by hop. On Arista 2, we did the same thing, continue checking events on the switch and trace source of the packets. We use the same commands, syslogs, MAC address tables, mirror to CPU sessions. We found out we are receiving the packets from Arista 1 and host 4. So again, we went to Arista 1, did the same checks, and we came to know that both Arista 1 and 2 are receiving unwanted packets from host 4. They were receiving the same ARP request by host 4 as well. So then we checked the network for any config or cabling mistakes. And what we saw is there was indeed an unwanted connection, unwanted cabling between host 5 and 4. So this was causing host 5's ARP request to go to Arista 4, but also to host 4, and host 4 was then sending it out in the network, and this was causing flaps. So we made sure that this was shut down, this interface was shut down, this link was shut down. And then we also spoke about in a layer 2 environment, whenever your hosts are connected to switches in MLAG, either put it in an MLAG port channel or make sure the NICs are in active passive state. So once we took care of the MAC flaps, the next thing we checked was why are the pings to the gateway unsuccessful? So we found out the expected traffic flow. It should be like this, again, coming in on Ethernet 8 of Arista 3. So we checked the config and we found out there was a MAC access list which did not have any entry permitting ARP packets. So the implicit deny in the MAC access list was dropping the ARP packets. We then added an entry which permits these ARP packets. And once the entry was added, traffic started flowing as expected. And then we also used counters per entry to verify the receipt of this packet. So that concludes the CLI troubleshooting part of the webinar. I hope that was helpful. I will now hand it over to my colleague Himanshu, who will talk about using CVP for troubleshooting such scenarios. Himanshu, floor is all yours.
Hey, Sarthak, thank you so much. Let me quickly share my screen. So, hello everyone, my name is Himanshu. I've been with Arista TAC with 5+ years now, and I've been primarily working on supporting data center technologies and Cloudvision product support. So today, similar to our previous webinars, what we are going to do is take a look at Arista CVP, short for Cloudvision Portal. For folks who are not familiar with CVP, just to give you a very high-level overview, Arista CVP is a turnkey solution for network workload orchestration and configuration management and automation. In addition to that, CVP also provides you a very powerful event-driven streaming analytics platform that enables you to monitor the real-time state of the devices that are being currently managed by CVP. Now, that not just includes the interface status, counters, but also the MAC address table, the ARP table, and the routing table. Now, this provides you a very useful bird's eye view of the entire network state available to you at one single point for monitoring, troubleshooting, and even for forensic analysis for issues that might have happened in the past. Now, as Sarthak has demonstrated, CLI continues to be the bedrock of troubleshooting network-related issues, which we saw using some very user-friendly and powerful EOS CLI show commands and packet capture tools like TCP dump. So in this particular segment, what we are trying to demonstrate is that with CVP, what we have already been doing in terms of troubleshooting on CLI, we can leverage this network-wide state that is available to us one single point to boost and improve certain stages of our troubleshooting process. Now, for this purpose of this demo, what I have done is I have already done a recording of using my lab CVP instance and a similar setup that we had seen earlier. So I'll be using that recording in order to for the later sections of this demonstration. So with that, let me quickly start with one of the very basic requirements we have whenever we are troubleshooting any network-related issues, and that is the topology diagram. So if you have ever been on a call with an Arista support engineers, one of the first things that they would ask you is the network topology diagram. Now, this is to get a better understanding of the overall network, physical and logical connectivities, which helps in visualizing a path a particular problematic flow might be taking. Now, the topology view on Arista not just provides you with the basic link level connectivity, but in addition to that, since we are getting the states of the entire switches, we kind of help us build certain overlays on top of that. So let me quickly switch over to my demo. Now, for the purpose of this demo, I am using Arista switches as hosts as well, wherein your typical production deployment, you would not have switches acting as hosts, but in fact, real servers. So that is a bit different, but the topology diagram is not going to be different in terms of how you would see in CVP, just the icons would be different. So instead of a Arista icon of a host, you would see a server icon. So you can see here, based on the information that we are getting from the devices, we have built the network topology diagram. So we can see Arista 1, Arista 2, and the host devices which are available out here. Now, we can go ahead and see the link level connectivity for all the devices. So for example, I can see we have Ethernet 1 and Ethernet 4 going to between Arista 1 and Arista 2. In addition to that, it also shows you what is the transceiver that is being used and what is the operational speed of that particular link. So I can see host 2 has a 10 gig connectivity to Arista 3. And similarly, host 1 has 2 uplinks going to Arista 1 and Arista 2, both 10 gig uplinks using a 40 gig transceiver. Now, that's just basic link level connectivity, how we can enhance on top of that and use it for troubleshooting. So Cloudvision also provides you certain overlays. Now, for the scope of this particular session, we are only focusing on the VLAN overlays. So once you click on that VLAN overlay, based on the L2 information that we are getting from the devices, what Cloudvision does is it kind of highlights the links based on the VLANs that are configured on the links and what are allowed on different links. So now using that information, I can see that, okay, between Arista 1 and Arista 2, all the VLANs are allowed, and likely it's got to be a trunk link. And host 4 is only present in VLAN 1, whereas my hosts 2, 3, and 5 are present in VLAN number 10. So this kind of helps me visualize better in terms of how my L2 topology is built or how the VLANs are stretched between different devices. Now, in addition to that, usually when we are troubleshooting network related issues, we try to narrow down our scope of our troubleshooting. So you can do that with Cloudvision, wherein you can filter down the topology. So for example, if you're troubleshooting hosts connectivity between host 1 and host 3, you can filter down the topology based on the VLAN. And now I have a much more narrower view, which I can focus more on troubleshooting, where I have filtered the topology based on my particular VLAN. So going ahead, what I'm going to do is I'm going to keep this topology view open in a different tab. We'll come back to this later on in the later segments of this particular demonstration. So with that, let me go on to the inventory page in my first tab. All right. So usually when we are troubleshooting layer 2 issues, we tend to check the MAC address table on the different devices. Now, since we have all the devices streaming to one single location, it becomes much more easier to troubleshoot in terms of I'm just a click away to check what are the VLANs that are configured on the device, what state they are in. I can also quickly check the MAC address table. So if you see here, the output is not much different to what you would see when you run the show MAC address table command on the CLI. You can see the host 1 MAC is learned in VLAN 10, it's dynamically learned on port channel 1, and we have only one moves for that particular VLAN. And quickly, I can check that state on my other devices. For example, I can move on to switch Arista 2 and check the same information there. Now, in addition to that, let's say if you're troubleshooting for an issue that might have happened in the past, or you're doing some forensic analysis wherein it was a short-lived issue and now the issue condition is no longer present. So you would say, okay, if I log into the switch now and check the MAC address table, show MAC address table command, I see that the MAC address table is correct. So how can I confirm the state when it was in the issue state? So with Cloudvision, you can go back in time very easily. So you can go back to a particular timestamp and check the MAC address table at that point in time to check if the MAC address table was correct at that point in time or not. So this is another use case which we can use Cloudvision to fill certain data points in our troubleshooting process. With that, let me talk about another feature which is very helpful in the initial stages of our troubleshooting. So usually when we are troubleshooting network related issues, we usually have very limited set of information. You would usually have the end host IP address or the MAC address. And typically you would go to the directly connected device and then try to check the MAC address table or the ARP table, and then go on hop by hop in the network topology path. Now with Cloudvision, since you have this entire data available to you at one single place, what you can do is, if you have the host information, you can make use of the endpoint search feature where I can just take, for example, the host 1 MAC address, input it out here, and see where all in the network topology this MAC is present. So the Cloudvision will run an entire scan on the entire data set that it has and show me where all this MAC is present. So for example, you can see it has detected this MAC was present on Arista 1. It was learned in the MAC address table, and it was learned dynamically. Now, in addition to that, it also detected that this MAC was also learned in the LLDP table. So that kind of indicates me that, okay, maybe the host is directly connected to this Arista 1 switch. And in addition to that, it also shows me that, okay, it was present on Arista 4 on Ethernet 3, it was learned dynamically. So it could be that it has happened via some sort of data plane learning. And finally, we come down to Arista number 2, where we can see it is learned as peer dynamic. So on port channel 10, which could be likely due to this switch is an MLAG with Arista 1, wherein it has learned or sync the MAC address from its MLAG peer. So the use case of this feature comes in very highlighted is in terms of very complex topologies. So let's say if you have a very big topology and you just like to save some time wherein you want to not waste your time looking at the devices where the MAC address table is consistent and focus your troubleshooting only on the devices where you would expect the MAC to be learned when it is not present. Now, if you see for this particular example itself, we saw that it was only present on Arista 1, 2, and 4, and it was missing on Arista 3. So what we can now do is, again, just for a verification purpose, we can go to the Arista 3 device and check the MAC address table to see whether or not it is learning the MAC address of host 1 or not. So if you go ahead to Arista 3, click on the MAC address table, and we see it only has the host 2 MAC address, but not the host 1 MAC address. So this way we can save a lot of time in terms of troubleshooting very complex issues or complex topologies, where we can save a lot of time in terms of isolating the devices where we want to focus our troubleshooting on. Now, going forward, usually what we have seen or what we do in our network troubleshooting purposes, like compare different states of devices. So that is again much more easier with Cloudvision, where you can compare two devices or a single device at different point in time. So for example, if I want to just do a config sanity check of between Arista 1 and Arista 2, and again, we are not just, we are only focusing our attention for this particular segment on the configuration and MAC address table. So for example, if Arista 1 and Arista 2 are in MLAG, and I have a dual home host which is connected via port channel to these two switches, I can quickly do a config sanity check where I can go ahead and confirm that, okay, if there is a MLAG port channel, whether MLAG ID is configured or not, or whether the VLANs which are configured on that port channel are consistent on both the devices. So this way, config sanity checks between two devices becomes much more easier. You can also check the MAC address table, where I can quickly verify if the host MAC is learned on both the devices or not. I can also check that for any other switch in the topology. So if you see out here, I can see that, yeah, host 1 MAC is learned on Arista 1, but not on Arista 3. So this way, this feature also helps in comparing multiple states of different switches at any point in time. Now, going forward, what we'll see next is usually in our troubleshooting process, we log into the switches and check the logging buffer. So you would run the show logging command to see what all logs have been generated, and that may help you to identify a particular issue. Now, this is also easy with Cloudvision, where the log messages are streamed by default. And in addition to that, just like you would do show logging grep a particular keyword, you can filter these log messages based on a particular keyword. For example, here we have seen LACP logs, and I can just see those particular logs in the logging buffer. Now, other scenarios where this is very helpful is, let's say, for example, it was a short-lived issue and maybe the log buffer got rotated and those log messages are no longer there on the switch. Or for example, the switch rebooted and we no longer have those log messages. Since Cloudvision stores the data for a very long period of time, I can go back to Cloudvision as my reliable data source and check the syslog messages of the device and kind of use that information to say that, yeah, this is why the issue might have happened. Now, based on these log messages and certain backend analytics that we do, Cloudvision also generates events. Some of these events are proactive in nature, some of them are reactive in nature. A very quick example of a proactive event would be, let's say if you have a certain issue on a device where the device memory is slowly decreasing. So Cloudvision will do certain estimations and kind of notify you beforehand and tell you, hey, just take a look at this device because I can see that memory is going into a critical state. Or it could be as something as basic as based on the syslog messages detected on the switch, the Cloudvision can generate an alert notifying the administrator saying that, hey, looks like this MAC address is flapping between two interfaces. So just check if something is going wrong on the switch. Now, where this particular feature shines its most is that these events can be forwarded to different platforms. So you can send it out to an email or Google Chat, Microsoft Teams or Slack, wherein now the network teams can react much more quickly and try to run the mitigation steps as compared to other scenarios where the detection and mitigation times are very slow. So this is where the events are very helpful. Now, going forward, we'll quickly touch upon one more aspect of Cloudvision, wherein let's say if you have a requirement to collect an output of a show command from multiple devices. So you can do that easily with snapshots. So I could have a show command, which I want to collect from a multiple set of devices. I can configure it as a snapshot. Think of it as a cron job, wherein I can specify the command. Cloudvision will just log into the device at a particular set of interval, grab that output and store it. This can be used for both active troubleshooting and for any forensic analysis or auditing purposes that you might use. So for example, if you see here, I have the MLAG snapshot available for Arista 1. I can check the output of show MLAG interfaces or show MLAG config sanity. And I can also check it for another snapshots that I have available. So I can check, okay, what is the output for show interfaces trunk, where I can just verify what is the forwarding state of VLANs on a particular set of port. I can quickly compare it to the other devices in the topology and kind of arrive at a conclusion, okay, if the VLANs are, the VLAN forwarding states are consistent as per the topology or not. So again, this is a very helpful feature in terms of if you're doing some forensic analysis and for any issues that might have happened in the past and you do no longer have that issue state available with you. Now, moving towards the end of this particular segment, we'll quickly touch upon a concept wherein, let's say if I want to view multiple metrics from devices at one single glance. So for example, let's say if I want to quickly check what all devices are in MLAG. So I can create a dashboard where I can gather that metrics from multiple devices and I can see that, okay, Arista 1 and Arista 2 are in MLAG as compared to other devices which are not. Or I can create an L2 metrics dashboard where I can aggregate that L2 information from multiple switches. For example, the switch port configuration of Ethernet switches or what port channel they belong to, or how many VLANs or MAC addresses are available on these devices. Now, these dashboards are very customizable, so you can customize it to any extent. For example, if you see here, I took these snapshots that I had configured earlier and put them all together in one place. So it becomes much more easier for me to compare these different states from multiple devices at one single point. So dashboards can be utilized to view aggregated information from multiple devices or multiple metrics from same set of devices. Lastly, we'll quickly go back to the topology diagram and we'll talk about something called as traffic flows. So usually when we are troubleshooting network related issues, we tend to identify, okay, what is the path a particular flow is taking while it is traversing the topology. Now, this particular feature does require certain configuration, additional configuration on the switch side, where you have to go down to the switch level and configure S-flow sampling. But once this is available, using the sampled flow data, so for example, you can see I am just providing the source and destination IP addresses and the protocol, which is in this case ICMP. Based on that, whatever flows are captured on the switch and streamed to Cloudvision, the Cloudvision can then use that flow information to kind of build an overlay on top of the network topology and show me, okay, what is the path a particular flow is taking throughout the topology. Again, in a small scale topology like this, it might not come as evident, but if you're troubleshooting a very large scale topology, this becomes very helpful, wherein I can see, okay, what is the ingress interface and egress interface per device, or what is the path a particular flow is taking throughout the topology. Now, again, as with Cloudvision, you can build an overlay on top of this as well, where you can filter the devices and say, okay, only I want to see for VLAN 10, and the topology will be narrowed down to show you only VLAN 10 devices and build the network flow topology on top of that. Now, with that, we come to the end of this particular demo. I'll quickly head back over to the slide deck. Now, the slide deck contains the snapshots and some additional information about the features that we discussed today. The reason why we wanted to talk about Cloudvision, because most of the times it might come forth as the metrics that are available on Cloudvision are mostly for monitoring purposes. But in certain situations, you can use these metrics as a troubleshooting data source for troubleshooting issues, and also to kind of bootstrap your troubleshooting process and save some time when you are troubleshooting very complex or large scale topologies. Now, all the features that we talked about today, the links for those features for the Cloudvision and the user guide are linked out here. So you can go through them at a later point in time. There are also very good videos that talk about these features. So you can go through them and try to understand what these features do and maybe use them into your troubleshooting day-to-day process. With that, let me hand it back over to the moderators. And if there are any questions, feel free to post them in the Q&A and we'll be happy to address them.
Thank you, Himanshu. Could you please move on to the next slide? Perfect. Thank you so much. So thank you, Sarthak, and thank you, Himanshu, for the deep dive and covering this topic in detail. Really great technical stuff here. And we really hope from the entire crew side that this session was useful for all the customers who were able to attend today's webinar session. Again, the recording of these sessions will be available on the Arista community page, along with the presentation material and all the questions what we have covered today. I think today we covered almost around 100 plus questions in the Q&A section. So thank you so much for the collaboration. And I do want to let everyone know that our session 2 in this Q1 series is scheduled for the 22nd February at the same time, 11 a.m. US Eastern. In that session, we are actually going to cover a different topic with the almost the live debugging scenarios which are actually going to span over a typical layer 3 setup. So today we covered the layer 2 setup with the help of CLI and Cloudvision. In 22nd Feb session, we are going to cover the debugging of a layer 3 setup. We will also be sending out a short feedback form after the webinar with 2 or 3 questions. So please do take some time to provide the feedback, as we definitely intend to use it for our future sessions. And at this point, I'm going to keep the webinar open to answer any questions what you may have. You can use the Q&A manager to ask our panelists any questions at this point. And I see that there's one question. Himanshu, probably I think you could provide some clarity on that. Which version of CVP we were using as part of this webinar?
Hey, yeah. So this one is using the latest CVP version 2023 release. So I'll mention that in the slide deck as well.
Perfect. Thank you so much. And I think there's a question from Ben. When will the videos be available? Ben, the videos along with the presentation material and all the details will be available within 24 hours. We'll be sending out an email to all the folks who have registered for this webinar. And also, this will be available on our Arista Community Central page. Um, And Asad mentioned that, thank you, Asad, for your feedback. Any possibility to get the config of the switches? Definitely, we'll be posting the sanitized configuration along with the presentation material on the Arista Community Central page. Definitely, that's a good ask, and we'll make sure that we do that. If I'm not able to join, yes, definitely. All the sessions in these webinar series, along with the previous ones, what we did in the 2022, they were recorded. The previous recordings are also available on the same Arista Community Central page. We have a placeholder for the TAC webinar, what we are maintaining. So all the previous recordings are available there, and like the presentations, what we are going to do this year, are also be made available on the same page. I think there's a question from Biruk. Can we use all troubleshooting commands like packet captures, session monitors, and etc. on the production environment? Yes, you don't have to take care of any sort of like additional steps to apply these commands before like applying these troubleshooting commands on your production devices. So definitely you're safe on that point. And I any other question? Um, think that so during network field day, Arista presented a CVP and there was an additional tab in CVP for applications. When will this generally become available?
Yeah, I'm answering that, but that will come
Okay.
later this year, and that will be available on our cloud service.
Perfect. Awesome. Which quarter of 2023 we can anticipate VXLAN HAR and VXLAN BGP EVP and troubleshoot sessions? So that's a great question. Actually, this year our plan is to drive into more technical topics, and we are actually going towards that. In the Q1, we are going with Layer-2 and then Layer-3, and then in our upcoming sort of like presentations, we definitely plan to cover the EVPN and VXLAN related troubleshooting sessions. Most likely, we'll come up with this during our fall collection of the webinars, what I mentioned earlier. But if the schedule of these webinars and the topics, what we are going to cover, this will be sent out, beforehand. So you have the updated information on the schedule and what we are going to cover beforehand. Okay, there's a comment from Amaris. Yeah, definitely. I mean, we are ready for all the questions what you may have. Feel free to, like, if you are not able to take any questions on the webinar live, tech-webinar is your go-to alias. You can definitely drop any questions what you may have to that alias, and we'll try our best to get to all the questions, even if we are not able to take it live on the presentation today. Any VPN webinar scheduled? Right now, we have it on the schedule. We actually are still sort of like putting the material together because it takes a lot of preparation and sort of making sure that everything is at the same high level and quality material we want to present to our customers. So we do have it in the pipeline. It will be available most likely in our fall collection, and we'll make sure to send out the updated flyer and details before that happens. Will we always get email invites? Yes, we'll make sure that all our customers who have registered for the webinar today or our past webinars be sort of sent out the invitation and updated information and the invites beforehand. Okay. And I think there are some questions, so our moderators are going to take those questions in the chat. And Thank you so much for this excellent feedback, everyone. We really appreciate the response what we have received, and from the on behalf of entire crew, we would like to thank you for your collaboration on these webinars. Do you offer or share any initial lab configs videos or session details? All these webinar details again will be available, and we do have a virtual EOS device, like the download templates which are available on our Arista page, so you could use that to spin up your lab topologies. Definitely you can do that. Would it be helpful if Hotmail has supported, like we actually for our registrations, we actually try to make sure that the customers who are attending, they are using the company domain emails. So if you're registering for our webinars, please do that. We actually at this point are not planning to allow any generic emails. So you can register on our webinars using your company domains, emails. So no lab access as such we are providing as part of the webinar, but you can, like, the configuration and all the material will make it available. And you can actually use that material to spin up your virtual lab using the Arista virtual devices, which are available on the Arista website in the software download section. Okay, I think at this point we have almost taken all the questions. So if there's nothing else, then we are going to wrap it up. Thank you everyone for joining us today, and thank you so much for your time and collaboration. See you all in February for the second webinar. Thank you all.